Alright, class, let's delve into chapter 1.4, equations of lines. So, first thing we need to know is the slope-intercept form. The form we use the most. Slope-intercept form, the equation of a line with slope m and y-intercept b is y equals mx plus b. Okay, so m is your slope, your y-intercept is b, obviously your m's here, your b's there. Okay, then you just got a y and an x. So, this example says an appliance repairman charges $60 for a service call plus $25 per hour for each hour spent on the repair. Write the equation. Okay. Y equals, okay. Now he's going to charge you $60 regardless of how long he stays. That's your constant. That's your B. We'll write that last. But he also charges you $25 per hour for every hour spent on the repair. That's your slope. That's your 25. So y equals 25 times however many hours x that he winds up staying plus that $60 that he's going to charge you regardless. So the equation that's going to tell you how much you get charged is y equals 25x plus 60. Easy enough. Let's look at the point and slope form. So this is another equation that's used sometimes, where essentially you can get a point and the slope and you can come up with the equation of the line. So the point slope form of the equation of the line. The equation of the line with slope m that passes through a known point x1, y1 is y minus y1 equals m times x minus x1. Now, in this example it says write an equation for the line that passes through the point -1, 5 and has the slope 3/4. Okay, remember that this goes x, y. So your x point's first, your y point's second. Easy enough. So all I've got to do is start it out in this point slope form. So y minus y1, which is 5. That equals the slope of your line, which is 3/4, times x minus x1. X minus x1, so I have minus a negative here. Minus a negative makes it a positive 1. Okay, and if you're a little unclear on that step, essentially what this was x minus a -1. Here, I just went ahead and simplified it in a single step and made it x plus 1. Okay, so your answer here is y minus 5 equals 3/4 times x plus 1. That's a point slope form. Number 2 says, the table below gives the number of drinks and the resulting blood alcohol percent for a 180-pound man. So you have the number of drinks x, and you got the blood alcohol percent y. A says, is the rate of change of blood alcohol percent for a 180-pound man constant? What I could see here is 3 to 4, that changes by 1. 4 to 5 changes by 1. 5 to 6 changes by 1. 6 to 7 changes by 1. 7 to 8 by 1. 9 to 10 by 1. Okay, everything seems to be going up constantly on the top. Let's see if it also goes constant on the bottom. So 0.07 to 0.09. That change is 0.02. Now 0.09 to 0.11, that change is also 0.02. And from 0.11 to 0.13, that change is also 0.02. And from 0.13 to 0.15, that's also 0.02. And if we go all the way up, 0.15 to 0.17, 0.02. 0.17 to 0.19 is also 0.02. And 0.19 to 0.21 is also 0.02. Everything's going constantly. So is the rate of change for the blood alcohol percent for a 180-pound man a constant? Yes, it is. Okay, easy enough. Both go by constants, so they stay the same. This one goes up by 1, this one goes up by 0.2. It's constant. That's pretty simple and straightforward. Now if I continue on, B says write the equation of the function that models the blood alcohol percent as a function of the number of drinks. Okay, so we're looking at modeling the blood alcohol percent as a function of the number of drinks. So your blood alcohol percent is going to be your y. It's going to be a function of x, which is the number of drinks. So your number of drinks here is going to be your x. So if I go back up and look at the chart, okay, so number of drinks is obviously your x, blood alcohol percent is your y. So if you know anything about slope at this point, rise over run, y's over x's, essentially what your slope is going to be here is 0.02 over 1. That's your slope, or your m. Alright, now if we want to do it and write it as a function, then y equals your slope, which I'm simply going to write as 0.02 because that's what it reduces to. Okay, now if you started out this way, because you want to write y as a function of the number of drinks, if you're starting it out this way, you're going more towards slope intercept, which is fine. You're going to have an x here, and then you're going to have a plus b here, right? And then you're going to take a point from your graph above here. So say the point 3 and 0.07. So 3 was your x, 0.07 was your y. You'll have to substitute those points in so that you can solve for whatever this b is. Now, the cool thing about point slope is you don't have to do that. What you could do instead, using the point slope formula, you could say, okay, my full formula is going to be y minus y1 equals my slope, which is 0.02. I think I have a little space over here, times x minus x1. And your x1 here is 3. So since we are focusing on point slope in this particular one, this would be the equation here that shows y as a function of x, or in this case, that models blood alcohol percent as a function of number of drinks. Okay, that's point slope form. So I'm going to write point slope as just a little abbreviation PS. Now you can find the slope intercept form as well. You could take this one and simplify and go there, or you could do like we were doing here and substitute these things in and solve for b. That's perfectly fine as well if that's the form that it's asking for or the form that you want to put it in. Now number 3 says write the equation of the line that passes through the points, and it gives you 2 points. So you've got -1, 5, and you've got 2, 4. Now in order to do this, what you're going to have to do is you're going to have to wind up finding the slope, and then you have to make a decision of writing it in point slope or slope intercept. Okay, so first off, let's find the slope. So to find the slope, we need to do y2 minus y1 over x2 minus x1. Alright, so doesn't matter which one's x1, which one's y1, you just have to keep them constant. So if this is x1, obviously this one has to be y1, which means the other ones are x2, y2. So if we do it in that manner, we're going to get 4 minus 5 over 2 minus -1. Okay, when you do that, 4 minus 5 is going to be a -1 on top. 2 minus a -1 is actually going to be a 3 on the bottom. So our slope, or our m here, is -1/3. Now, let's go ahead and write this in slope intercept form. So y equals -1/3 x plus m, or plus b, excuse me, plus b. We have to solve for that b. In order to do that, what we need to do, we need to substitute one of these points in for x and y. Looking at it, none of them cancel really super easy, but let's use 4 for y and 2 for x. You could use the other one too, it'll work out just the same. I'm just using that one. Okay, if we substitute those in, what we get is 4 equals negative 1/3 times 2 plus b. So that what we get is 4 equals negative 2/3 b. Plus b. And add that 2/3 to the other side, so that what we get is b equals 4 plus 2/3. Now, you're not going to want to leave as b as 4 plus 2/3. You're going to want to convert it. Okay, so if I found a common denominator for this, so your common denominator would be a 3, which would mean that 3 times 4 is 12, would be your new numerator here. So 12 over 3 plus 2 over 3 would give you 14 over 3. So your b here is 14/3. And you're like, okay, now we've got our b, we can put our whole everything together, so that your final answer here in slope-intercept form would be y equals negative 1/3 x plus 14 over 3. And that would be the solution to your problem. So that's the answer to number 3. Now you could also do that in point slope if you wanted to. It all really depends on what the question asks for. So I'm trying to show you a few different ones in a few different ways. But you need to be prepared to do both. Number 4 says the number of people in millions in U.S. prisons or jails grew at a constant rate from 2001 to 2013, with 1.345 million people incarcerated in 2001 and 1.570 million incarcerated in 2013. A says, what is the growth rate of people incarcerated from 2001 to 2013? So it's simply asking for the slope here. So we can find the slope. Alright, so what we need to do, okay, what we're going to do is essentially do the subtraction just like we were doing. Okay, so if I choose 2001 to be my x1, y1, whatever, I just need to make sure that I pair that 2001 with that 1.345 million people. So it's probably a good idea, since it is growing, to put your bigger numbers first. So if I do 2013 first, minus 2001, that means the corresponding one with 2013 was 1.570. I need to be sure to subtract that from the one that was corresponding to 2001, which was 1.345. Okay. Now 2013 from 2001 is pretty simple. It's just 12 and 1 point. Let's check. You should have your calculator right there and be able to work with it. But 1.50 or 70 minus 1.345 should give you 0.225. Okay, now all you have to do is divide that by 12, which you can do in your own calculator. So should give you a rate of 0.01875. So the rate of growth of people incarcerated from 2001 to 2013 is 0.01875. B says write a linear equation that models the number n of prisoners as a function of the year x. Okay, so we want to model the number of prisoners as a function of the year X. What we can do is we can do two things. We can write it in slope-intercept or point-slope. Okay. In part C, it's going to want us to use the function to predict the inmate population in 2017. So if it's going to want us to do that, we're probably going to want to do slope-intercept. So we're going to want it written as y equals mx plus b, okay, which means we'll have to solve for a b. Now what we can do, if we don't really want to mess with that solving for b problem, we can start with point slope and we can convert that to slope intercept. I think that's what I'm going to try to do here. So if we do y minus y1, or actually here, let's erase this. We want it as an n. So models the number of prisoners n as a function of the year X. So we'll use n minus our n1 here. So it doesn't matter which one you choose. You can use the one from 2001 or you can use the one from 2013. I'm going to use 2001. So n is the number of prisoners. So the number of prisoners associated with 2001 is 1.345. Okay, that's going to equal your slope, which is 0.01875. Okay, times x minus your corresponding x1 here, which is actually 2001. Okay, so if I want to get n by itself, what I'm going to have to do here, one, I'm going to go ahead and simplify this right hand side. So I'm going to keep this left hand side as n minus that 1.345. Okay, I'm going to distribute this slope here, which is 0.01875. So that will go to the x. And I'll need to multiply that times that 2001 as well. So we'll get minus, if I do that real quick on my calculator, what I get is 37.51875. Now obviously all I have to do next, if you're following along, is add this 1.345 to both sides. So I'll have to add it over here as well. Okay, so that I get a final function, I change colors, that looks like n equals oops, got a little carried away with my pen here. N equals 0.01875 x, and then minus, you'll have to subtract those two numbers here, so we will do minus 36.17375. That's always a good idea to check behind me on your calculator and make sure you can get that as well. So here's your function in slope-intercept form. Obviously that was your function here in point-slope. So now you've gone from point-slope to point-intercept. Now in C, we're going to use the function to predict the inmate population in 2017. Now all you really have to do for that is plug 2017 in for X. Okay, but what I'm going to do is I'm going to go over here on the TI calculator really quick, and I'm going to show you how exactly to type that in. So let's go. Alright, so over here on your TI, I've got it typed in 0.01875 times 2017 minus 36.17375. All you got to do after typing in is hit enter, and it gives you the answer of 1.645. And that's pretty much that simple. If you wanted to get more complex, you could try to type it in your y equals, and then you can go to your table and try to find 2017, which would be kind of outrageous to scroll that far, or you could use some of your functions like your second calc function to try to find it if you could set your window up correctly. But this one's pretty simple to just type in. You get your answer as 1.645. Alright, so back over here we have our answer as 1.645. The important thing to note in this problem is that we're talking about millions of people. So it's a good idea to write your units. So you can just write 1.645 million. Now if we move on to number 5, it says write equations for lines that pass through the point and have, the first one says slope 0. So, okay, if we think about a slope 0, right, that means we rise none, we run none, which kind of makes not so much sense. But if we think about it in another sense, we've got a XY axis here, right, and it's not the prettiest. So -1 up 5 is going to be somewhere right here. Okay, guesstimate. Okay, now a slope of 0. Now if we're thinking about 0, 0 could be rewritten as 0 over 1, which is still 0, 0 over 2, which is still 0, could even be written as 0 over, say, 15, which is still 0, which means we rise none, but we can run as many as we want to in either direction. So honestly, what this is a horizontal line right here that passes through that point. Now, if you also want to think about it this way, if it has a slope 0, y equals 0x, right? And then you got to know where it hits on your y-axis, right? What's your y-intercept? Well, your y-intercept, if I change colors, is right here, which is actually 5. So it would be plus 5, which is just your y value in your set right here. So a slope of 0 means it's a horizontal line, which means I could write the equation just like this, y equals 0x plus 5, where simplified is just y equals 5. So a slope with 0, really all you have to do is choose your y value and set your y equal to it. Now, on the flip side, if you have an undefined slope, the other cool thing with it is the undefined slope here works kind of the opposite way. So undefined slope means that I have a 0 in my denominator. So you can have whatever in the top. So I could have, say, a 3 in the top, doesn't matter, but I have a 0 in the denominator. That would be an undefined slope. Okay, you could have anything in the top, so you could have anything other than 3 as well. You could have a 15, a 10 million, whatever. This is an undefined slope. So what happens is it's still going through this point. So it's still just like this. And if I want to regraph it, like I said, these are not perfect graphs by any means, obviously. But if you're going over -1 and up 5, say that point's right there, I want that line to go through that point and have an undefined slope, which means it could be the same as 0 underneath the 3. So 3 over 0, which means I rise 3, run none, rise 3, run none. So that's just a vertical line, okay, through that point, which means that what I'm actually going to have here, very similar to what I had here, we're just going to have an x equals -1, because x always equals -1, right? My y doesn't change here. My x just always equals -1. So my y could be anything here. So y could be 0, x is going to be -1. Y could be 4, x is going to be -1. Y could be -16, x is still going to be -1. So my equation is simply x equals -1. So with an undefined slope, all you have to do is choose your x value, and that's the equation of your line. With a slope of 0, you just have to choose your y value, and that's the slope of your line. And that's how that works. Pretty simple, right? So let's move on. So, vertical and horizontal lines defined. So a vertical line has the form x equals a, where a is a constant and a is the x coordinate of any point on that line. A horizontal line has the form y equals b, where b is the constant and b is any y coordinate on the, or is the y coordinate of any point on that line. Okay, so that's pretty simple. Now what gets a little more complex for people is the parallel and perpendicular lines. So a parallel line means that two distinct non-vertical lines have the same slope and means they're parallel. Perpendicular line, if a slope has m not equal to 0, so can't have a 0 slope here, but as long as the slope's not 0, any perpendicular to it will have a slope of -1 over m, which is the negative reciprocal. So parallel line has the same slope, perpendicular line has a negative reciprocal slope. So in this question it says write the equation of a line through 4, 5 in parallel with the equation 3x plus 2y equals -1. So the biggest key here is we need to go ahead and find the slope. We know the slope will be the same because it's parallel, okay? But we have to find the slope first, which means we need to solve for y. So I've got y equals, okay, that's what we want to get it to. Now to get it there, we obviously have to subtract the 3x off, and we got to divide by 2. So if we throw some intermediate steps in here, I'm going to go ahead and subtract that 3x off so that 2y will equal -1 minus 3x. And all I did was subtract 3x from both sides so that this one canceled out, and then a 3x wound up on the right hand side. Then I'm going to divide by 2 so that what I get is y equals, okay, -1 over 2 minus 3 over 2x. Okay, and the thing that we're really worried about here is the slope for this one. So this is what we're after. Slope, remember, is always on the x. Doesn't matter the order here. The -3 over 2x can come first, or the -1/2 can come first. But what matters is the constant on your x. This is your slope, right? So this will be the slope for our new line as well. So our new line here will be -3 over 2 x plus b. Here's where your point comes into play. Now you can use point and slope and use that, but let's go ahead and do slope-intercept form, because slope-intercept form is usually what we use most of. Okay, we need to figure out what this b is. So I'm going to change colors again. We're going to get into actually figuring out what the equation of this line is. We have the slope for it, but we don't know what the b is. So we've got, what I'm going to do is plug this point in. So I'm going to say, okay, 5 is my y. That equals -3 over 2 times 4, which is my x, plus that b. Okay, so that what happens is we just need to simplify for our b. So I'm going to leave the 5 alone. 4 divided by 2 is 2. -3 times 2 is -6. If you don't see that, write you a few extra steps out and just simplify this -3 over 2 times 4. Okay, and then that'll be a plus the b. I know my 6's and b's look kind of similar. I apologize for that. That's a 6. That's a b. Now I just need to add 6 to both sides. And if I do that, I can see that my b is 11. Okay. Now with my b being 11, my answer to my problem here, the equation of this line is simply y equals -3 over 2x. And then plus 11. So this is the answer I'll be looking for. That line is parallel to our original line and goes through the point 4, 5. Now we need to do perpendicular. So it needs to be perpendicular to the line with equation 3x plus 2y equals -1. Okay. So we have already gone through and found what the slope of the original line is. It's that -3 over 2, because we have the same line here. this is exactly the same as this. Okay, but here we want it to be perpendicular instead of parallel, which means we need to take the negative reciprocal. So if I start my line out, it'll be the negative reciprocal. So y equals, slope's negative reciprocal. Negative reciprocal means that this negative will drop off and this will flip. So in reality it looks like this. Still the negative there, the negative on the outside, and then 2 over 3. And then the more simplified version will look like y equals 2/3 x. Okay. Negative reciprocal just means you take the negative of it and flip it. Okay. So I took the negative of it, which is what this negative is, and I flipped it. So in reality, you could skip this step right here perfectly fine and say, okay, the negative reciprocal of this 3 over 2 here is just 2/3, and that'll be x plus b. Then all I have to do is solve for that b. All you got to do to solve for that b is to plug in that 4 over 5. Okay, change colors so we don't lose track. So I'm going to plug 5 in for y. 5 equals 2/3 x. So that x is a 4. And then we need that plus b here. Alright, so that means, I'm still working through simplifying, 5 equals 4 times 2 is 8, so 8/3 plus b, which means I need to subtract 8/3 on both sides so that b equals 5 minus 8/3. Now you got to find you a common denominator, which I know isn't the most fun thing in the world, but it's not terrible. So common denominator will be a 3. If you converted this to a 3 on the bottom, it means you'd have to have a 15 on top. 15 minus 8 over 3, 15 over 3 minus 8 over 3, that should give you 7 over 3, so that your b is a 7 over 3. Now you can type up your original equation. I guess we will do that in brown, so that your perpendicular equation looks like y equals 2/3 x, and then plus 7 over 3. So your perpendicular equation that went through that point 4, 5, that was perpendicular to that original line, would be y equals 2 over 3x plus 7/3. And that's what I would be looking for. Now, we've talked about point slope, we've talked about slope intercept. Also need to mention the general form of the equation of a line. That general form is ax plus by equals c, where a, b, and c are real numbers with a and b not both equal to 0. So you can have one equal to 0, but you can't have both of them equal to 0. Okay. So if we review them all, your general equation is ax plus by equals c. Your point slope equation is y minus y1 equals m times x minus x1. Your slope intercept is y equals mx plus b. Your vertical equation, or equation for a vertical line, is x equals a, and your horizontal equation, or your equation of a horizontal line, is a y equals b. Okay. The next thing we'll go into is the average rate of change of f of x with respect to x over an interval from x equals a to x equals b, where a is less than b. And it is calculated as the following. The average rate of change equals the change in f of x values over the corresponding change in those x values. So that your equation looks like f of b minus f of a over b minus a. It's very similar to your slope, except that you can find the average rate of change on a line that's not necessarily straight. So you can find it with curves, you can find it with all kinds of different shape and curvature lines. Okay. Essentially what you're doing is finding the secant line when you find the average rate of change between 2 points on this graph and the slope joining those lines between the 2 points. So essentially what that average rate of change is the slope of your secant line. Alright, so if we move on to this page, hopefully it'll make a little sense. So in this example it says sales and projected sales for the electric powered Tesla automobile are shown in the figure. The number of Tesla sales can be modeled by the function S of t equals, and it gives you the function for it there, where S of t is in thousands and t is the number of years after 2010. A graph of S of t is shown in figure 1.39b, which is just right below. Okay, so it says find the average rate of change of S of t between 2 and S of 2 and 6 and S of 6. The reason I put the graph here is to kind of give you a visual. So let's use something kind of bright. Okay, so 2 and S of 2 just means you go to 2 on the graph, and wherever it hits your line, that's your point. And do the same thing with 6. So we'll go to 6, and we'll try to go up here as straight as we can. So S of 6 hits maybe about right there. So we essentially want the slope between those 2 points. Well, the slope between those 2 points isn't constant. So what we're going to do is kind of take an average slope. Okay, so essentially you're not having to worry about this curve. All you're doing is finding the slope between those 2 points of that straight line, or approximate straight line, because it's kind of hard for me to draw straight on here as well. But instead of having to worry about the curve all in between, we want to find the average rate of change between those 2 points. So this point here and this point here. Okay, if you want me to, I can even do it in a different color. So that point, obviously, and that point. Okay, it's really, like I said, not that bad. Alright, so if we're looking at this, A says find the average rate of change of S of t between 2 S of 2 and 6 S of 6. So put the bigger one first. You'll have S of 6 minus S of 2 all over 6 minus 2. Now 6 minus 2 is obviously 4. That's pretty easy. We need to find S of 6 and S of 2. Now to do that, what you're going to wind up doing, you're going to come up here and you're going to plug 6 in for all these T3s and T2, T squareds and T's, and you're going to solve it in your calculator. And then you're going to come back and you're going to do the same thing with 2. Okay, you're going to come over here, you're going to plug 2 in for that T cubed, 2 in for that T squared, and you're going to plug 2 in for that T as well and solve it on your calculator. I feel confident that you can take those numbers and type them in your calculator and figure that out. If you struggle with that, please let me know. Now, I can already tell you that those numbers are going to be 99.28 and minus 1.896. Okay, so double check them, make sure you can get those once you type those 2 in. Alright, now all you have to do is simplify. You can simplify in 1 step or 2, it doesn't matter to me here. You can do the 99.28 minus 1.896. You should get something like 97.384, and then divide that by 4 and you get 24.346, which will be your answer here. That is your average rate of change between those 2 points. Now obviously that leads into B, which says what is the relationship between the slope of the secant line joining the points 2, 1.896 and 6, 99.28, and the answer part A, they're essentially the same. So they're the same exact thing. So hopefully you're able to follow that along pretty easy too. Now the next part gets a little bit tricky and a little bit into it, so try to hang on. It's the difference quotient. So for h not equal to 0, the slope of the secant line joining the points x and f of x, and x plus h, f of x plus h, and the average rate of change of the function f of x from x to x plus h is, and you've got this function that says f of x plus h minus f of x over x plus h minus x, which simplifies to f of x plus h minus f of x over h. So it's a complicated looking function. It essentially just takes the slope of the secant line function and simplifies it. Okay, so that you can add any constant to your x and find that the slope of the secant line with this formula. So in this example it says for the function f of x equals x squared plus 1 whose graph is shown, find f of x plus h. Okay, so let's find that really quick. All you're doing is plugging x plus h in where this x is at. So it'll equal parentheses x plus h squared plus 1. Now you do need to simplify that. So you'll have to FOIL out that x plus h, which essentially, if you don't remember what foiling is, you really need to go back and review it. You're just multiplying x plus h times x plus h, and you do need to keep that 1 tagged on the end as well. So that if I simplify it, what I get is x squared plus 2hx plus h squared plus 1. Okay, so that would be your answer for that one. B says find f of x plus h, and there's supposed to be a parentheses here. I thought I fixed that by now, but I'm sorry, it's been left off. So there's supposed to be a parentheses here. So we want to find f of x plus h minus f of x. Okay, we're going to work up a little bit, one, so we can see what we typed, and two, so that we can, have a little space to work it out, because you can tell that my marker right's a little big. So we found this first part. I'm just going to repeat it. X squared plus 2hx plus h squared plus 1. Okay, so that part corresponds with this f of x plus h here. Now we need to subtract off. So we need to subtract off just a regular f of x here. Now if you go up, remember your regular f of x is just x squared plus 1. So I'm going to subtract off x squared plus 1. Okay, and then we're going to simplify. So we'll simplify in a completely different color altogether. We need to distribute this negative here. So it needs to go to the x squared, but it also needs to go to the 1. Okay, so if it goes to the x squared minus x squared is going to cancel this out. 1 minus 1 cancels those out. So that really all I'm left with is 2hx plus h squared. Okay, so that is what this is equal to in B. Alright, C says the average rate of change with the difference quotient. We want to find the average rate of change with the difference quotient for this, for h not equal to 0. So we have this top piece. We've just solved for it. So all we got to do now is divide by h. So if we do that, 2hx plus h squared divided by h. Okay. Now I can take an x from each of these. That'll leave me with a 2x plus h, simplified. Okay. So your average rate of change with your difference quotient when h is not equal to 0 is 2x plus h. Okay. Here's a little graph of it, which essentially says I can choose any point x, move an amount h over, and the slope of this secant line from point to point is going to be that 2x plus h with this particular equation, y equals x squared plus 1. Okay, simple enough. So how that works, I guess for a little explanation here, how that works is, say my original x here, and I know it doesn't match with the graph, but say my original x here was, I don't know, let's do 1, if my original x is 1, so let's do original x is 0, right, which means my original y is 1. So you can clearly see that's the point 0, 1 right there. Okay, if I move my x, if I move my x 1, so if my h equals 1, my original x was 0. To find the slope between x and x plus 1, essentially all I've got to do is say, okay, my original x was 0. I'm adding 1 to it, so that my new slope is 2 times 0 plus 1 is 1. Okay, if I move 2 over, essentially what I'm doing, okay, my original slope here, still 0, moving 2 over, so plus 2, so my new slope of that secant line between x of 0 and x of 2 would be 2. Okay, that one's pretty easy. That's kind of how that works. Number 2 says, suppose a ball is shot straight upwards at 64 feet per second. The equation that gives the height of the ball t seconds after it is shot is f of t equals 64 minus 16t squared. Find the average velocity of this ball over the time interval from t equals 1 to t equals 2. Okay, so you could go through and find that function we just found if you wanted to, or you could simply use the 2 time intervals here. I'm going to just use the 2 time intervals. So we'll definitely do a 2 minus 1, the 2 comes first. But then we need to find f of 2 and f of 1. And we need to subtract those as well. Okay. So like I said, the 2 minus 1 part, that's really easy. That's just going to be 1 on the bottom. Right? So we need to find f of 2 and f of 1. So come over here, f of 2, that's going to be 64 minus 16 times 2 squared. Now 2 squared is 4, right? 4 times 16 is actually 64. 64 minus 64 is simply 0. You can double check me if you want to. So f of 2 is 0. Need to go on ahead and find f of 1 as well. Okay, so we're going to get 64 essentially minus 16 times 1 squared. Which is essentially 64 minus 16. 64 minus 16 should give us what, 48? Which I believe is correct. So that what you get here is 0 minus 48 over 1, which simplifies simply to negative 48. So that your average velocity of this ball over the time interval from t equals 1 to t equals 2 is negative 48. okay? And it's actually velocity, so you can dibble and dabble on the units there, okay? Should be in feet per second, I believe. Feet per second. Okay. B says find the difference quotient that can be used to find the average velocity of this ball over the time interval from t equals 1 to t equals 1 plus h for h not equal to 0. Now this is where we have to go up here and we have to use this equation, this difference quotient equation. So that what you're doing here is you're finding f of x plus h minus f of x all over h. Okay. Now, the cool thing here is I already know what my t is. Okay, so my t is 1, so I can go ahead and plug that in. I already know what my number here is when t equals 1. So essentially what you're saying here is this x here is the same thing as your t. That t is a 1. So I don't know exactly what my h is going to be, obviously, but I know what one thing at least is going to be here. So I'm going to have here a 1 plus h in the first one, because that x is a t and the t here is essentially a 1. Also in the second part I can substitute this here. I've got f of a 1 because my t is 1. I can substitute in here a 48 for that. So that's what I'm going to do. So it's actually a minus 48. So it'll be minus a minus 48. Okay, because that's kind of what we found here. Nope, it's not, is it? Sorry. I erred. It's not a minus 48. That was the average velocity. We were actually looking here to substitute this f of 1 right here. So make sure I get that straight. So this goes in for that f of 1 that was right here. So it is a minus 48, but not a double negative. And make sure you can see that that is indeed a 48. I know my handwriting can be rough at times. Okay. Don't know if that was any better. But all this is over h. Okay. Now what I need to do is I need to figure out what this f of 1 plus h is. Okay. If I come down here, I need to use my original equation. So I need to use 64 minus 16 times 1 plus h, and that's got to be squared, minus 48 all over h. Okay, so that if I FOIL this just like I did the other one, I'm going to leave you to do a little side math because I don't have but so much space. If you need to FOIL it step by step, be my guest. I don't care how much time or paper you take to do that, but I'm going to skip a little bit. So 1 times 1 would be 1, 1 times h would be h, and you'd have 2 of those. So you're going to have plus 2h, and then h times h is h squared. So that if you FOIL it, you should come out with something that looks like this. And then you're going to come out with a minus 48 as well. Okay, all that's over h. Now the next thing you're going to have to do, I'm going to change colors to kind of show this to you. You're going to have to distribute this negative 16 to everything inside this parentheses. Okay. So if we do that, and I scroll down a little bit to give us some space to do that, still going to have this 64 out front. We're going to have a minus 16. Okay, minus 16 times 2 is going to wind up giving you a minus 32h. Minus 16 times h squared is going to be a minus 16h squared. Okay, and then a minus 48. All over an h. Change colors again. What you'll notice is if you combine negative 16 and negative 48, you get a negative 64. So that if you want to, you can cancel out the 64 with the negative 16 and the 48, and that essentially becomes 0. So what you're left with here is a negative 32h minus 16h squared, where you can then, if you're following, take your time, pause if you need to, catch your breath, you can cancel this h with this h and one of these h's, so that what you get is negative 32 minus 16h. Okay, so this is going to be the difference quotient that can be used to find the average velocity of the ball over the time interval from t equals 1 to t equals 1 plus h. So if I wanted to find it from t equals 1 to t equals 3, my h there would be a 2. I could just plug a 2 into this, and what you would find is that if you plugged a 2 into this, you'd wind up, I believe, with a negative 64, which, if I'm not mistaken, nope, not exactly quite. It's quite the same as what we did up there, I don't believe. So, yep, because we plugged a 3 in. So, and it would work with the one above as well. So if you plugged a 1 in, like we did here, and then your other one was a 2, your difference would be a 1. Negative 32 minus 16 is the negative 48, which matches with what is above if you follow my statement there. Alright, moving on to page 7. Number 3 says, Table 1.16 shows the real and projected enrollment in thousands at U.S. public schools for selected years from 1980 through 2024. Okay, you've got this big table here. It says find the average rate of change of the high school enrollment between 1980 and 2024. So we're really looking between these 2 years. Now all kinds of stuff can happen in the middle, but we're really just worried about the average rate of change between those 2 years, which means that we are going to set it up with our big division sign here. Okay, so what's going to go on top is our y's and the bottom is our x. We can see that our x's here start with 2024. The big one comes first, minus 1980. Okay, and we need to do that 52,113 minus that 41,651. Okay, so if I do this, obviously the bottom simplifies pretty easy. So the difference between 1980 and 2024, I believe, should be 44 years. The difference on the top is a little more difficult. Let's type that in the calculator real quick. Take it a second. Type it in your own calculator. You should get 10,462, I believe. So that if you simplify that and divide it by 44, you should, I believe, wind up with 237.77. And if you believe I'm wrong, please let me know so that I can correct it for everybody else. But I think I'm right. So the average rate of change of enrollment between 1980 to 2024 looks like 237.77 thousands of students. Okay. B says write the equation of the line determined by this rate of change and one of the 2 points. Okay. Now I'm going to take the easy way out here. I'm going to use point slope formula because it didn't tell me which one to use. If it tells you to use slope intercept, obviously use slope intercept. Okay. But I'm going to use point slope. I'm going to say y minus, let's do 1980. Y minus 19, nope, sorry. Got ahead of myself there, didn't I? Making sure you're paying attention. I hope you're like, I don't know why he's writing 1980 there. He should be writing the y value there for 1980, which was 41,651. Keep you on your toes, even when I'm online. How about that? Okay, then you're going to write your slope. Then you're going to do your x minus your x1, which in this case is that 1980. Okay, so that is your point slope formula. Easy enough. Now, I've got a whole host of examples down here on the next 2 pages that we're going to run through real quick. Most of them are pretty simple, just help you refresh some of the stuff that we've gone over. So this one says write the equation of the line for the given conditions. We have a slope of 1/3 and a y-intercept of 3. You should very simply be able to say that that's y equals 1/3 x plus 3. Doesn't get any easier than that. Now this one says through the point with slope. So let's use point slope. Y minus y1. So y minus a -6 equals the slope here, which is -3/4, times x minus x1, which is your 4. You should go through and simplify here and say, okay, that's the same thing as y plus 6, which equals the same thing on the left hand side, -3/4, x minus 4, and you've got the point slope formula here. Now you got a vertical line here passing through the point 9, -10. Now you got to think, if you have a vertical line, what stays constant? Your y's are constantly changing, so what stays constant is your x. Say, so your x is what stays constant, so your x is what you write. So x equals 9. That's it. Now you've got this line here passing between 5, 2 and -3, 2. Now you can do the slope equation if you want to, but what you're going to find if you do the slope equation, so you've got your x's and your y's, you're going to wind up with a 2 minus 2 over a 5 minus a -3. Okay, so you're going to wind up with 0 on top, which means that your slope here is going to wind up being a 0. So anytime you have a 0 slope, right, it's going to be a horizontal line, which means you only need to choose your y, which in this case is 2. And that's simple enough. Now 8 and 9 get a little more complicated. It says we want to pass through the point 4, -6 and parallel to the line with the equation. It gives you the equation, which is slightly incorrectly typed. There needs to be a y there. So 3x plus 7y equals 4. Even I make a typo here and there. Apologize for that. Let's solve this for y real quick. So 7y equals 4 minus 3x. We'll divide by that 7 so that we get a slope here of -3/7. So that's really all we care about. We don't really care about anything other than this slope right here. Okay, and x isn't included in the slope, but x, the slope is in front of that x. So if we want it to be parallel, then what we're looking at here is y equals, right? If we want to do it in y-intercept form. If you want to do it in point slope, let's go ahead and do it in point slope. Y minus y1, so that's actually going to turn to a positive because we've got 2 negatives, equals, okay, we've got a -3/7 slope here, times x minus, our x1 here is a 4. So in point slope form, here's what we've got. We've got y plus 6 equals negative 3 over 7 times x minus 4. That's really, really simple. Now, we've got another equation here, and we want to find a perpendicular line, and it's got to pass through this point, negative 3, 7. Okay? And you can do this in both slope-intercept or point slope. So I'm throwing a little bit of both at you here. We still got to solve for y first. So change the colors back. So I'm solving for y. I'm going to say, okay, 3y equals 7 minus 2x. I'm going to divide by 3 on everything. And now that I can see that my slope that I'm really concerned with here is this negative 2/3 that's in front of that x. Okay, so what I'm going to say here, okay, I need to find the negative reciprocal. The negative reciprocal of this is going to wind up being 3 over 2. Hopefully you can see that, because the negative is going to make that negative go away. 3 is going to go to the top, 2 is going to go to the bottom. We're looking at perpendicular, remember? Perpendicular. Alright, so I'm going to do point slope again, just keep it really simple. So we're going to do y minus y1, which is your 7, equals our slope here, which is 3 over 2, times x minus x1. So x minus a negative 3 going to give you a positive 3. If you like writing more steps than what I'm writing, feel free to do so. But I feel like you can cancel out negatives and make it a positive pretty easy. Now 10, we want the equation of this line. Okay, so you can clearly see it hits right there, right? And that's where it hits the y-axis, which means that that is your y-intercept. Okay, so we've already know that our b equals negative 5. Okay, found that out real quick because we just looked at the graph and used a little bit of common sense. Now, you've got the graph here as well. So, the cool thing about having a graph is you don't have to do the y2 minus y1 over x2 minus x1. You can count. You can do rise over run. Okay, so we got to figure out how much we rise and how much we run. Now, if you like doing the hand math, by all means go ahead and do it, have fun with it. I'm just trying to show you another method. So we're rising from here. You got to watch your scale. Okay, we're starting at negative 11 and we're going up to 7. Okay, so if we're going up from negative 11 to 0, that's 11 that we're going up. Then we're going up 7 more. So we're rising 18 from negative 11 to 7. Okay, and then we're going to run. So we're starting here at 2. We're actually going to run, okay, because we started at negative 11 and rose to 7, I've got to start at 2 and go to 4. I can't go the other direction. Okay, so we're rising 11 here, and we're running back to the left, which makes it negative. So we're going to go 2, 4, 6. Run to the left 6. Now if you want to start at this point, drop 18, and then run 6, that's fine too. You'll wind up with the same thing, because you'll drop 18, which made the 18 negative. You'll run 6, which stays positive. You'll still wind up with 18 over negative 6, or if you want to write it the other way, negative 18 over 6, which is the same thing. Now 18 divided by 6 is simply going to give you a negative 3 here. Okay, so if I go write this equation, I'm going to go y equals negative 3x minus 5. And that's the equation of that graph. Easy, easy, easy. Alright. 11 here says, write the equation of a function if its rate of change is negative 8 and its initial value is negative 7. Okay. So we've got to look at the rate of change and its initial value. Okay. So this one's pretty easy too. Y equals your rate of change. It's negative 8. That'll be at x. Your initial value is negative 7. That's your b. Good to go. Okay. For the function y equals x squared, compute the average rate of change between x equals -1 and x equals 2. Okay, so really what you're looking at, put the bigger number first, 2 minus -1, okay, which means we need to find an f of 2 and subtract that from f of -1. So that's an ugly f. Let me write that one a little bit better. Alrighty. Simplifying the bottom's easy. You get a 3. Okay. Need to figure out what this f of 2 and this f of -1 are. Okay. I plug 2 into my function here. 2 squared is 4. I plug -1 into my function here. -1 squared is 1. Okay, so I get 4 minus 1, which is 3. 3 over 3, which is 1. So my average rate of change here is just 1. And it's that simple. Okay, 13 says for the function y equals x to the third, compute the average rate of change between x equals -1 and x equals 2. Same thing, start with the big one, go to the small one. 2 minus -1. Okay, same thing, we need to find f of 2. Subtract that from f of -1. Alright, 2 minus -1 is still a 3, just like it was before. If I plug 2 into x cubed, 2 times 2 is 4, times 2 is 8. Okay. Now I got to plug -1 into x of 3. -1 times -1 is +1. Times -1 is -1. So what I wind up with here is 8 minus a -1, which is a 9. So I get 9 over 3, which is just a 3. So my average rate of change for this one is a 3. 14 says for the function shown in the figure, find the average rate of change from -1 to -4. Okay. The cool thing about this one, it gives you a graph. We can kind of do the whole graph thing. All we're doing is really connecting these 2 points, right? So we can just find the slope between those 2 points, which means we can do rise over run. We're going to rise 1 or -2 down, -4, -6. So we're dropping here. We're dropping vertically. We're dropping vertically 6 units. So our rise is -6. And that puts us here, and then we're going to run. Now our units change here. We were going by 2s here, we're going back by 1s here. So we're going 1, 2, 3 units to the right. So that what you look at here is our average rate of change here from there to there. Simplified is just -2. Now if you want to do the average rate of change function, be my guest. But all you really do is got to count it. So rise over run. We rose -6. We ran 2. You got to watch your units here. I'm sorry. We rose -6. We ran 3. So you got to watch your units here because your units can be different on your different axes. Alright, so for the functions given below, find f of x plus h minus f of x over h for h not equal to 0. Okay, so all you're doing here, okay, you're plugging x plus h in for this. So 45 minus 15 times x plus h. Okay, then you're subtracting that from the original f of x, which is 45. You need to keep that in parentheses too. 45 minus 15x. And then you're putting it all over h. Okay, the biggest thing about these is they can take some paper sometimes. Okay, now let's look at what cancels. So this negative needs to be distributed here, and it needs to be distributed here. If you keep that in mind, you'll notice that that cancels with that, and we're going to have to distribute this as well, so we'll take an extra step for this. So we get -15 x minus 15h. Okay, minus a negative 15, so that winds up with being a positive 15x all over h. If you notice, if I change colors again, this cancels with this, that h cancels with that h. All you wind up with is a negative 15, which makes sense because this is a linear equation, and your rate of change, which is essentially your function here that finds that, of a linear equation, is just going to be your slope. Okay, this one's a little different because it's squared, it's not a straight line, so it involves a little bit more work. A matter of fact is what I'm going to do, because I don't have a whole lot of space here, and I feel like you're capable at this point. Give that one a shot, and if you have any problems with that one, let me know. Okay, so try 16 on your own. That way I don't have to try to cram it in that little space. I believe you can do it. So follow the outline for the one above. Simplify as best you can. If you get stuck, let me know. Now 17 says verify that the values satisfy a linear equation and write the equation to the linear function if one fits the data. Okay, so from 1 to 7 I'm increasing by 6. From 7 to 13 I'm increasing by 6. From 13 to 19 I'm increasing by 6. So let's make sure that the difference between these increases constantly as well. So from negative 0.5 to 8.5 I'm increasing by 9. From 8.5 to 17.5 I'm increasing by 9. From 17.5 to 26.5 I'm also increasing by 9. So I believe it is a linear function. That seems all well and good. Okay, we want to write the equation of the line, which means we need to find the slope, and after we find the slope, we need to actually find the equation. So if I'm looking at this, okay, the difference in y's over the difference in x's, so my slope here is going to look like 9 over 6, which reduces to 3 over 2. Okay, that means that y equals 3 over 2x plus some b. Okay, now you can plug any of those in to find b if you'd like. I'm going to plug the very first one in. So I'm going to say, okay, negative 1/2, which is the same thing as negative 0.5, equals 1 times 3 over 2, or 3 over 2 times 1, plus b. Now if I subtract off 3 over 2 on both sides, what you'll notice is negative 3 over 2 minus 1/2 will actually wind up being negative 4 over 2, which is just negative 2. So your b here is going to be a negative 2. And like I said, if you need to take a few more steps to simplify that, please do and verify your answer. So that your final equation here, and the answer to this will be y equals 3 over 2x minus 2. Alright, number 18. A company charting its profits notices that the relationship between the number of units sold X and the profit P is linear. If 300 units sold results in 4,650 profit, and 375 units sold results in 9,000 profit. Write the equation that models the cost function. Okay, so what we're going to do here, we're essentially going to take these two things, we're going to find the slope, and then we're going to find the actual function off of that slope. Okay, so what we're going to do, 300 units, 375, we're going to do 375 first. That's going to be our x1. So we'll do 375 minus 300. Those are your x's. That means your y's are going to be 9,000 minus 4,650. Okay. Then all you got to do is simplify that. That'll give you your slope, your m, right? Then all you got to do from that m is use your y equals mx plus b equation. Okay. And then what you'll do is you'll take either one of those points. You'll take either 300, 4050 and plug it in for x and y respectively, or you'll take 375 and 9000 and plug it in for x and y respectively, and you'll solve for your b. You can do that. I've gotten you almost all the way there. 19 says a ball is shot straight upward with its height in feet after t seconds given by the function f of t equals 112t minus 16t squared. Find the difference quotient to find the average velocity of the ball from t equals 3 to t equals 3 plus h seconds with h not equal to 0. Okay, I'm gonna get you part of the way there on this one too and let you finish this one on your own too for some extra practice. Okay, so what you're gonna do, you're worried about that difference quotient, which you gotta remember is f of x plus h minus f of x all over h. Okay, now the secret to this one, right, is that t is 3. T and x are basically the same thing here. So that what it looks like is f of 3 plus h minus f of 3 all over h. Okay, so that what you can do here, we'll put it on this line and I'm going to let you solve the rest of it. Okay, you're going to do 112 times 3 plus h minus 16 times 3 plus h squared, which you'll wind up having to FOIL out, minus parentheses 112 times 3 minus 16 times 3 squared all over your h. Okay, now this takes a good bit of simplifying. It takes more simplifying than I have pages at this moment. So that's why I'm going to let you finish it yourself. You set it up. We've got the whole setup here. Now all you really have to do is the algebraic simplification. Okay, if you can do the algebraic simplification, you've got this whole problem. If you need to take it piece by piece and simplify the pieces, take it, do it piece by piece and simplify the pieces. But this is chapter 1.4. This finishes chapter 1, which means that after you're done with this, you can start the chapter 1 quiz. Okay, if you have any questions about the ones that I'm making you finish on your own, try as hard as you can on them. And then if you have any questions, let me know. And I can get back to you and make sure we clarify those questions. Other than that, appreciate you watching. Hopefully you followed along, got it pretty easy. And I will see you on the next lecture.